So I'm going to switch to GenAI applications on Google Cloud and notably Cloud Run. And we'll first describe what are GenAI apps. Then we'll take a closer look at reference architecture of one of them, how Cloud Run helps for different pieces. And then we'll go into a demo with Lisa. So overall, we've all been seeing that over the past few years. Generative AI is transforming how we interact with technology. And that's also the case when you develop application yourself. Like maybe, as a developer, you have an AI code assistant. But that's also the case for the applications that we develop, where now part of those applications include a language model, for example, or an AI model more generally. And so we'll go into those application types. I'm going to skip over the next few slides, but as Yunong shared, Google has been in the AI space for a very long time with very different projects that you've been hearing about. And notably, one is TPUs, are a long-term investment from Google. And the latest in Google Cloud, Gemini is both a model that you can use as a service, and also it's an AI assistant. So now let's talk about GenAI applications. A very popular framework to build language-based applications is LangChain. And the LangChain team themselves, the founder, actually shared that Cloud Run is the easiest and fastest way to get your LangChain app running in production. So why is he saying that? So first, let's take a look at what are those types of apps. So this is a high-level architecture diagram for a GenAI app that is RAG capable. So RAG means Retrieval-Augmented Generation. It basically means that in addition to using a language model in your application architecture, you also need to query a database to enrich the response of the language model with your own data. That's how you get way more accurate responses when you query a language model, is if you pass not only the user prompt as an input, but also a lot of context that you retrieve from your own database. So at a high level, we have three systems. The main one, like a web application, is the serving subsystem. So the service subsystem really works like a request-response web API or web service, right? And so the users will send requests, and the goal of that system is to return a response. Ideally, this system streams a response back to the user, because sometimes the response can take a very long time to compute or can be very long. So by streaming it back to the end users, you actually get an impression of speed for this end user. So there is a serving subsystem. Then you also need to ingest data into this database. So you have a data ingestion subsystem that will populate the database that is read by the serving subsystem. And you also want to ensure that this overall application is of good quality. So you have a quality evaluation subsystem. We will deep dive into each of these. Let's double click. So that's a bit scary, but I'm going to go over each system as an individual slide. Okay, so the serving subsystem, what we can see is that you are going to be using Cloud Run services for that. You often have a front end, like serving a web page with some client-side code, and a back end which will orchestrate this application logic. And this back end is where you will run something like LangChain. So LangChain will be like taking the user prompt, enriching it with some context, querying the database for adding context to the prompt. And so this database is a vector database. This context is stored as, you search it using vector search, and then you retrieve the data stored in the database. Then a key specificity of that serving subsystem is that it will make an API call to a language model. So in Google Cloud, we have Vertex AI that offers the latest Gemini as an API endpoint that your application can query. Your application could also query your own language model that you run yourself, for example, on GKE. And then this language model will return a response. You might even stream it back to the user. And all of that, of course, is monitored and logged with cloud logging, cloud monitoring. So that's the serving subsystem. The data ingestion subsystem, the goal of that subsystem is to transform, for example, every time there is new data to be taken into account for this GenAI app, this subsystem will transform that data and store it into the database. So for that, you're going to be subscribing to a cloud storage bucket, for example. Every time there is a new file in that bucket, it will trigger a Cloud Run service or a Cloud Run job. And it will potentially use like document AI to extract information from this document. It will retrieve the vector using the embedding API of Vertex AI, and it will store all that into the database. So that's how you keep that database up to date, by having a data ingestion system that is decoupled from your serving system. And finally, the quality evaluation system, here it's pretty simple. It's like it runs on a schedule. For example, every day you want to run a set of golden prompts to make sure that your application returns correct responses for those prompts that you care about. And you want to track that quality over time, and hopefully you want to make it go up. So let's see how Cloud Run can help. You see there is this small arrow logo is representing Cloud Run, so we'll see how Cloud Run can help for each of those subsystems. But here, I really want to call out the actual language model does not run on Cloud Run. It is consumed as an API by using, for example, Gemini on Vertex AI. But you can see that around that API, you need a lot of pieces to build an application around it. So the serving subsystem, you will be using Cloud Run services. So here, as I said, it's a request-response flow that orchestrates the retrieval-augmented generation, prepare the prompt, calls the inference endpoint of Vertex AI, and formats the response back to the user. So we've talked about Cloud Run services. You know now that they have an out-of-the-box HTTPS endpoint. They auto-scale on demand. You have a revision history, as you remember. And they can run any container, and therefore any GenAI framework, like LangChain is one of them. But LangChain has a Python version, a JavaScript version. Cloud Run is not opinionated about that. Use whatever fits your needs. You can stream the response back to the end user. And as Sridhar described, it is enterprise-ready, notably via direct VPC connectivity.
So the Cloud Run service is, when it's labeled as a service, it's intended to be always on. It's running, it's available.
So it is always exposing an endpoint, but if it is not receiving any request, and you've not configured it to set a minimum number of instances, it will scale down to 0 and cost you nothing.
Okay.
So the endpoint will always be here, so that when there's a request coming to that endpoint, a new container is spun up, processes that request, and after a while, it will go back down to 0.
But in that instance, you're going to experience some latency as that image comes back online, becomes available,
yeah,
which is fine.
This latency, as we've seen in my demo, we've seen some requests taking 2 seconds to process. So indeed, it is a 2-second latency compared to 300 milliseconds in the case of a warm container.
Sure.
But on one hand, it costs you nothing. Just you add 2 seconds of latency, which, if that is acceptable for your users, probably going to be saving you a lot. If it's not acceptable, you can actually configure Cloud Run to never scale down to 0, to scale down to a number of instances that you want.
Okay, that was going to be my next question.
And when those instances are not processing requests, you actually pay way cheaper for them. Because they don't have CPU allocated to them, but they are here in case a request comes up, the CPU gets allocated and the request gets processed. And in that case, that's how you reduce those cold starts.
Yep.
To build on that question, that's configurable, correct? You can keep it always on.
Right, absolutely. The default is scaled to 0.
Yep.
You can set any number of minimum instances.
Because I can see use cases where you have multiple databases distributed across different areas where to spin it up, the common use case you were just talking about, it's milliseconds, right? But if you have multiple use cases or multiple databases where you're spinning up different instantiations, it's going to take time for each one.
Yeah, it indeed depends on how long your container takes to start. Now, I want to call out, I do not recommend to run stateful workloads on Cloud Run. Like the database that we've been seeing in that diagram is actually AlloDB or Cloud SQL, so that the Cloud Run service only runs a stateless compute container that can be auto-scaled.
Well,
So
let's take a step back for a second.
Yeah.
So before we talked about running stateful style containers, not sitting in volumes for persistent data, right? But on an external database, and that was fine. But I want to make sure that there's not a contradiction here, because then you just said to not run stateful workloads.
By that I mean those container instances can come and go. As a consequence, architect around that. So if you store data, store it in a database that is not like an in-memory database, right? Use like AlloDB, Cloud SQL.
Right.
If you store files, store them in cloud storage. If you need a cache, use Cloud Memory Store Redis or Memcache.
Yeah, so stateful and persistent style workloads are fine in Cloud Run. We just obviously want to make sure that we're not storing
The things you want to persist permanently, you put them in a Google Cloud database, you put them in a Google Cloud blob storage, or even if you want some caching across your container instances, you'll be using a managed Redis.
Got it.
Okay, but with that though, like the promise with Cloud Run is to simplify that operational component and being able to have the platform available and be operated in a more simplified manner. So is it that in Cloud Run, you're also going to be simplifying the access and the connectivity to those spaces? Or are you doing that today?
I didn't get the time to show you, but to connect Cloud Run to Cloud SQL database, you would have a built-in integration. And that integration will manage for you a proxy that will add an extra layer of security when you connect to that database. Instead of connecting just through a public, don't do that, but a private IP, you will add an IAM layer when you connect to that database. And that is all managed for you by Cloud Run instead of you having to manage it.
Right, so it's not about don't build stateful apps within Cloud Run. It's that when you build the stateful apps within Cloud Run, you're going to utilize the best services, and we're going to provide that easy integration capability.
If I can rephrase it, Cloud Run can be used to build stateful apps on Google Cloud. Like you need to use the whole Google Cloud platform. Cloud Run will be running those containers, and Cloud SQL will be your database.
Right, but the important
integrate well together.
Yeah, but the important part that I was trying to get to is the main value prop here comes in simplifying the management of running that app from a platform standpoint. So if you're, mitigating, complexity by integrating access to those services within the
those are all best practices anyway. You have a question?
Say something. When you put the slide about the LangChain saying this is the fastest way to production, are you doing some kind of a reference scaffold or application here, or is there a base image that people should be using, or is there just the pure fact that Cloud Run is fairly easy to use is why this is the way? It's
twofold actually. One is obviously if you go from zero to a deployed LangChain app, like Cloud Run will do that for you. Like as you've seen, it took us 10 seconds to deploy. But two is indeed LangChain framework is recognized by Cloud Run when you deploy from source code. So if you have a Git repository with a LangChain Python application, Cloud Run will literally be able to build that repository into a container image and deploy it on Cloud Run. Like you have no custom configuration to make to your source code to deploy it. It is literally compatible with the default LangChain web server.
Instead of building your own container image, you can point it at a repository and say, this is a LangChain app. I know how to build it.
Right. Cloud Run will detect, oh, this is Python. Oh, it is a web server listening on that port. I can build that into a container and deploy it.
That's clearer now.
So but is that a feature? Is that a feature of Cloud Run, or just that you have pre-built components?
So at its core, Cloud Run is a container runtime.
Right.
But its experience allows you to deploy from source code. So what happens when you deploy from source code is that the first step is to detect which language that is, and to use Google Cloud build packs, which are done by our team, to transform that source code into a container image.
Okay.
So, yes, we say Cloud Run can deploy source code or Cloud Run can deploy from Git, but Actually, what we mean by that is Cloud Run will detect the source code, will automatically build it into a container with not having to create any Docker file, and will deploy it as a container on a container runtime.
So in that case, it really is simplifying the developer experience.
No need to learn about Docker. You can just point at a Python app, a Java app, a Node.js app, a Go app, PHP app. All of these will work out of the box. So last slide before we jump into a demo. So for the two other subsystems, data ingestion. So here we would be using the Cloud Run job, as we described earlier in this presentation. This Cloud Run job will prepare and process the data and load it into the database. And for quality evaluation, I think we can combine two things that I love, Cloud Run jobs, and something that is so simple in Google Cloud that we often forget it. It's called Cloud Scheduler. So Cloud Scheduler is simply cron as a service. You want to run something every day, just open Cloud Scheduler and say, oh, okay, run that at midnight every day. And Cloud Scheduler will simply execute a Cloud Run job at midnight every day. And this Cloud Run job can fan out to as many tasks as you want. For example, each task will evaluate one prompt for your application. And so Cloud Run jobs are on-demand execution of any code. You don't have to write any web server. It's literally code that executes to completion. They are on-demand, automatic, rapidly scalable. You can run up to 10,000 tasks, many in parallel. Each task can run for 24 hours. And you can, as I said, execute them on a schedule. And of course, you have built-in execution history and logging and monitoring.
But for this to work, you're deploying that code as a container. Like you're delivering your own container. It's not a serverless job that's going to run on a Google Cloud serverless function or whatever. Like,
so the Cloud Run execution environment is indeed container-based.
Mm-hmm.
By the way, Cloud Function is built on top of Cloud Run,
Mm-hmm.
which is in the end container-based.
Mm-hmm.
And in that case, you have the same source deployment experience as I described. So if you don't have a container that encapsulates your job, you can just type gcloud run jobs deploy in a folder which contains a Python script.
Yep.
And in that case, Cloud Run will package that Python script into a container image and run it serverlessly.
Perfect.
Yeah,
Right.
but
That
you
is
don't have to
helpful.
think about containers.
Yeah, that's helpful.
And I think we can jump into a demo, or if you can.
All the content that everyone has talked about so far into a demo. We can build a LangChain-based app and using Gemini and to deploy it. All right, so let me actually talk through the app for a moment. So this basically is a web-based app, let you, query supported features on Cloud Run. Like we have a number of supported features in Cloud Run, right? And then the web is a web-based app, let you, we're going to use a Retrieval-Augmented Generation to enhance Gemini for more accurate response. So this is an example in the slides. If can I mount a cloud storage bucket on Cloud Run, and then the app was going to find the release notes that are relevant to the query, and then it's going to prompt Gemini with this information, and it will give an answer. And then we're going to break this app into a two-step approach, okay? So the first step, we're going to use Cloud Run jobs to import the release notes. The release notes basically is in the public website to a vector database. So the vector database, we're going to use Cloud SQL, pgvector extension. Vector basically is a numerical representation of your text and images, right? And then the vector database allows you to do the similarity search. The great thing about similarity search is that you'll be able to find the information not only fast, but also be able to find information by context, by meaning, not just by the keywords. So if you say, I'm going to search a happy dog, it's going to return a dog wagging its tail, for example. So it's pretty powerful. And for the embeddings, we're going to use Vertex AI embeddings. Okay, so actually that's enough talking. Let's take a look at let me share my screen. Let's take a look at the code. So for this particular task, we've written just a simple Python code. We did import some of the libraries that we're going to use in this demo. And then, of course, we're going to retrieve all the Cloud Run public release nodes from which is stored in the BigQuery right now, and then we're retrieving them. That's the step one. And then we are setting up the next piece of code. We're setting up the the pgvector instance there. Get the connection to the Cloud SQL database with the password. All these environment variables we're getting from the
Sorry, on the libraries that were being imported. So let's say this is an application that like you weren't running in Cloud Run before, right? And you want to bring something in and run it in Cloud Run. You're going to have to refactor a bit based on the libraries that you're utilizing to work with Cloud Run, right?
Yeah, you need to set up certain.
Okay.
Correct. So and then so we are setting up the pgvector instance, and then we're going to actually to convert the release nodes into the vectors. We're going to call in the Vertex AI embeddings API, and as you can see here, I specified a model. We're going to use text embedding Gecko model from the Vertex API. So once we set it up, and then we're going to actually, it will perform the conversion, and it will save all the release nodes into the vectors, into the Cloud SQL database. So this is just a simple Python, it's a Python code. And then next step, you just go to the terminal. I don't think I have time to do the actual build, but I know that some of you asked how you're going to turn the code into a image. And then so this is one simple gcloud run command. What it does, it will actually turn the Python code into a container image, and then store the container image in the artifact registry, in the container registry, and then it will deploy this image into a Google Cloud Run. So it will.
That's an image you can pull down. So like I can use like a Docker pull on that image.
You don't even need. This is the command it would do. I mean, there's some additional parameter, environmental variables. And
short answer, yes.
Yeah.
What that does, it pushes to a registry, and then you can pull it using any Docker tooling that you want. You can even scan this image for vulnerabilities in the registry.
Got it. Okay.
Thanks.
Cool.
Thanks, Steren. So here I did build this yesterday in prep for this session. So we have the indexer built here in the Cloud Run jobs. So you can actually look at the logs. We just examine the code. You can see actually the logs shows my application that I have to retrieve the number of release nodes from the BigQuery. There are 200 also release nodes, and then we save the 200 also release nodes in the Cloud SQL. If we don't have time, but if so, you can actually even look at it into the Cloud SQL and then examine your pgvector database there as well. So I also want to mention one of the things that Steren has talked about. So this is a one-time background task that we use Cloud Run jobs to execute it in one time, right? But in the production workload, Cloud Run has a great feature velocity. So it actually has features, every week or whatever. So you want to set up a trigger actually to do this, execute this background job in a periodic basis. So you always get the latest information in your vector database for your user query. So you can actually, we have this Cloud Scheduler actually is a built-in in the Cloud Run. You can set it up on a daily basis, weekly basis, whatever frequency you want. And then you set it, once you set it, you forget about it. This thing will run automatically based on your requirement.
So you can set up these cron jobs, but is there a way to set up these triggers based on like an event that occurs? It's all cron right now.
Right now, it is this particular one is Cloud Scheduler, but I guess you could use some other pops up, for example, to based on the events trigger type of thing.
Got it.
So you have other options as well. So that's the first step. So let's go back to the slides quickly. So that's the first step. We've done this release nodes conversion into the vector database. And then now let's actually take a look at the main logic of this application, right? So for this, we're going to use the LangChain. So in my environment, I actually use LangChain CLI to set up a base folder that it will populate some of the base files. And we're going to use LangServe. LangServe app actually provides you a very nice playground where you can actually examine the prompts and then let you examine some of the intermediate. You can send the prompts to this playground and you can examine the intermediate results for your application and then inspect the result out of that. So the logic of this application is that, okay, user is a web-based interface, the user put in a query, right? And then you send the query to a nodes retriever where you're going to call the pgvector database to retrieve the similar release nodes to the user query. And then you're going to put the original query and the release nodes to your prompt template to construct your prompt. Once you construct the prompt, you send it to your large language model, and then we're going to get the response out that to the user. So for that, we're going to use the LangChain to help us to expedite the application. So let's actually take a look at the code before we see the actual application running. So if I open up my code, I have a directory called run rag, and then this is actually gets populated by the LangChain CLI. It will create a base folder with some of the files. The server.python file is actually created by the LangChain CLI. I just need to populate my code, the logic for my application into this base code, right? So I need to import some of the libraries. And then if you look at the main logic we put in here, again, we need to actually initialize the vector store because we need to connect to our Cloud SQL database. And then we need to use the Vertex AI embeddings to convert my user query to a vector, and then the pgvector can do a similarity search, okay? So once we retrieve the similar release nodes to the user query, we're going to build this out, and then we're going to create a prompt template. In this case, what I'm telling Gemini is that, hey, you're a Cloud Run expert, you're going to answer these questions, right? And then use the user query and also the information I provided to you and give me a concise answer. So this is the prompt construction portion. And then the fourth step is that we're going to specify, hey, I'm going to call the Gemini model here, and then I actually set the temperature to be 0.2 so that it doesn't get too creative, just stick, basically, it's more predictive for me. And the max output token I set up to be 100. And then finally, we're going to use the LangChain to put everything together and then send the response back to the web application. So we put up everything. Again, if I go to the terminal, I can use this one gcloud run command to compile the code and then build the image and then send to the Cloud Run to deploy this particular container image. And then to save time, I actually have this deployed yesterday. We can, of course, also kick off the build, but I don't think we have that much time. So this is built yesterday, and then the image is called a run rag, right? So if we go examine, nice thing about Cloud Run service, this is actually great for all your internal, external web applications, because then it will give you automatic URL, and then you can click on this URL. And if you can see the minimum instance is 0, so you don't have traffic, then it's scaled down to 0. This Steren talked about the concept here as well. So, so it will bring up the application. Okay, so this is the LangServe application, the LangServe playground, and then let's just test out this application. Let's say, does Cloud Run support, let's say, direct VPC egress and when, okay? So this is, and this again will go through all the steps we just talked about. Actually, it came back with an output to say, yes, it does support, and here's the date. And the nice thing about LangServe app is that it gives you all the intermediate steps that actually we went through the logic of my code, right? We look at, how we construct the prompt, how we does the node retriever, right? You can see all your intermediate steps there. It's just much easier for you to do the debug for the GenAI app. And then let's say if we do the reset, and then let's do one more query, does Cloud Run helps me run faster? Okay, let's see how does it respond. All right, the question can be answered. That's because how we tell the application to do, right? This is out of its scope. So this pretty much, yeah, one more thing, and actually I want to mention is that, so if we have time, we don't have time, and then if I kick off another build, we can have multiple revisions here, right? And then, I think Steren talked about this. You can use Cloud Run to also manage traffic. With the latest revision, you can say, I put 5% of the traffic there to test out the production before I actually roll 100% of traffic into that. So I think that's all I have. And then if you guys interested, we do have this collab available in our website. We'll share the link later on. And then to close up, we just see a GenAI application that is built based on the context aware and then relies upon the large language model to do the reasoning. And we've used the LangChain app to help with it's basically a flexible toolkit for building the GenAI applications. And then Cloud Run is really our enterprise-grade serverless platform that gives you the developer velocity. And it's really a perfect match to run all your LangChain and any other GenAI applications. So that concludes the session.